right, listen, I got 12:02, so why don't we get going? I meant to have the web page showing when people came, but this is the 29th Northeast Digestion Roundtable meeting hosted by Northeast Biosolids and Residuals Association. We've been doing this since April 2016. We've been sponsoring these quarterly meetings to share technical and operational experience and advance some best practices for anaerobic digestion. It's not really a webinar, it's a more meeting in a roundtable format. We'll have a presentation and then we'll open up for discussion. I know the presenters value feedback they get from all of you who design, operate, and permit these anaerobic digesters. So everyone should be muted, hopefully, and just stay on mute until after the presentation. Then we can have a free-for-all questions, answers, comments. I am recording the session and I'll put the link to the recording on the web page and I'll email it out to you guys next week. So today we'll be hearing from CCI BioEnergy and Evergreen Environmental about their hydromechanical, it's a pulping depackaging technology for organic materials capture and contaminant removal. And this is especially important as we move to more co-digestion of biosolids and food waste at anaerobic digesters. So joining us today are Ward Janssens with Evergreen Environmental and Tommy Frost from CCI BioEnergy. I'm going to introduce Ward, although a lot of you may know him already, and then I'll let him introduce Tommy. Ward has a long-time track record in organic waste processing internationally, including Canada and the US. He's the founder of Evergreen Environmental and its subsidiary, CCI BioEnergy. Previously, he was a co-founder of Listech International and co-founder of Orgo World International, both with facilities in Canada and the US. So as I said, this is intended to be more of a meeting, a roundtable format. I'm going to ask Ward to go ahead and share his screen. We're going to leave some time at the end for questions, so you can get going. And
that's good. Thank you, Janine.
Let's do
I
it.
will do that. I will start sharing the screen. Does that work?
Yep, if you want to just put that in presenter mode. And if you have questions, you can type them in the chat as they come up. Gang.
Okay.
Take it away, Ward.
Evergreen CCI BTA. Co-digestion of organic waste. And this is about hydromechanical preprocessing in combination with degridding. And so what we will be discussing is proven technologies, proven experience. And so this is not about doing new stuff. Our background, as for design, build, own, operate, former Orgo World, with including SSO, source separated organics, pre and post-consumer, mixed waste, wastewater treatment, specifically industrial wastewater treatment. Former Listech was involved as one of the co-founders of former Listech, and we took it from university level to full scale with first site in Ontario and then California at Fairfield Suisun district. And then obviously with BTA, CCI BTA, a lot of experience, including 60 facilities in different areas. One of them, two actually, Toronto source separated organics since 2002, initially at Dufferin, since 2014 at Disco, Varennes with CMAX, and including ultimately also a lot of mixed waste processing facilities. We're familiar with pre and post-consumer organics because not all organics come clean. Most of it collected. Pre-consumer is about destruction and out-of-date material. And post-consumer is obviously the more contaminant materials, which is included in programs like source separated organics, separating at source, but also mixed waste organics. So our experience is with contaminated, more difficult materials. A little bit about our background here. You see a number of facilities, including a few LISTAC facilities, one in Dundalk, Ontario, and one in Fairfield, Soussan. Facilities left up is Amsterdam, nice city, by the way. This one is just outside the center of Amsterdam. Composting facilities, mixed waste facilities, tunnel anaerobic digestion, composting wastewater, mixed waste. This is a mixed waste facility. So we've been in the UK, in Europe, and North America. Different types of waste, different types of processes, different technologies, and a significant number of facilities. This is Toronto. Toronto collects its waste pre or post-consumer residential waste. That is a site in Toronto. It includes, for your understanding, to collect the waste, the organic waste, in plastic bags to make it easy for the residents to contribute. Kitchen waste, incontinent material, kitty litter, diapers. Diapers is a big part of organic waste. In short, in summary, difficult materials. And this is what we're removing. By taking the materials and not destroying it, using hydromechanical pre-processing to separate out the packaging materials. And here you see, and you'll see it in the next slide, more in detail. We're not destroying the packaging material. We've learned in the past that destroying packaging materials, those processes do not establish capture rate, and they result in difficulties for treatment facilities and qualities of the products. You see here that we also are able to process diapers. And the nice thing to see here is that an unused diaper at 58 grams, 100% solids, ultimately weighs heavier than a post-processed diaper after our hydromechanical pre-processing. So we are removing, obviously, the organics content, including obviously the polymers which are in diapers. In the center, you see after degrading, so pulping first, then the 10 millimeters fraction goes through a degrading system. Here you see pits, eggshells, all that stuff removed. And you see that the system ultimately, but that's not important on the right side, is able to deal with bigger contaminants and materials without being destroyed, which is normally causing business interruptions, pieces of steel, bricks, and that type of materials. Here, it's a confined space exercise, half an hour to remove it, and you go. Here you see the evidence that the process of hydromechanical processing is not destroying packaging material. We're gently using water, processed water, and forces, movement in the hydromechanical system to open the bags and to separate, and to homogenize and defiber the materials. Here you see a very close picture of what we established with that waste. You see the eggshells. And as professionals, you will understand if you can remove eggshells and those very small pieces, that is highly valuable for equipment. This slide is in it to show you that the end product, the digestate end product, is free from sharps and plastic pieces. And it is compared with CASA's requirements, which is in fact the Carson facility requirement in California. So that is what we're establishing. So that waste, which you see, that dirty material, when it comes out of our pre-processing, it has a very good quality. What we've seen is that using different technologies for pre-processing, most of the technologies have and cause issues. And they cause issue for digestion, for composting, and other processes. With this result, because it's contaminated, there's less throughput, increased cost, lower output, and lower quality end product. And ultimately a deteriorating business case. Grit and sharps. So for that is it for the guys who are pre-processing that material. For digester operations, it's causing processing issues and quality issues. Because this is in fact what you see with organic waste processing, is that companies doing pre-processing and collection, pre-consumer waste, mostly, or post-consumer waste, if they do it, because in the US that's not generally done yet. That's where the most organics is for anaerobic digestion. But if you look at an average pre-processed waste from pre-consumer sources, you see grit, pieces of plastics, and small pieces of metal. And that's causing issues. And you see the end products with glass, sharps, plastics. In fact, to give an example, this is a pedal depacker, a high-speed turning pedal depacker, taking materials, pre-consumer, including packaging materials. This is what you see happening. So the pedal depacker is running the material through, and this is the residual waste. But in the residual waste, you see a lot of organics. So the first question is, and you see a lot of small pieces of plastics. So the question is, what are we establishing? Because a lot of organics is still going to landfill. This is the product they're creating. And it looks fine. The question is it fine? Because once it shows up to the digester operations, it shows all the contaminants. The same happens for presses. So most of those operations are shipping materials to digesters, which ultimately are causing initially issues for them, because there's all kinds of pieces of steel, etc., in it, damage. Wastewater treatment facilities in the middle at 2, they think there's fine, and 3, this is what they get because it's hidden in the pre-processed organics. And that is what's causing issues for pumps, for pipes, for digester cleanouts, as well as for the biosalts product. And there is wastewater treatment facilities, co-digestion facilities who are stopping taking this organic material, or they're leaking it into the headworks instead of directly feeding it into the digesters, losing at least 40% of the conversion capabilities of the material. In addition, the process is able to treat sludges. But that is specifically related to degrading. And I'll tell you more about that. On-site, off-site solutions. So we have on the left combinations, which is a combination of the waste pulping and contaminant removal part and degrading, or degrading only. We are using pre-consumer, post-consumer organics for the combination, and raw sludger or digestive cleanouts for grit removal. In fact, if you look at the pictures, you find us under number 1 in the area of pre-consumer organics, 2, post-consumer organics, source separated, or pre, we can take it immediately, or we can take it after it's pre-processed to clean it, to finish it. We can take the organic materials from mixed waste and prepare the feedstock for digesters free of contaminants. And we can take sludges as well as part of the solutions could be used for degrading. And for capture rate, and that may be a terminology which most of the people haven't been heard of, hearing of, that is, if we take that material, we are doing, you want to achieve a high capture rate, because otherwise you're still moving stuff to landfills. This system is, and this solution is establishing a high capture rate. It has also a high contaminant removal rate for plastics and for grit. We know, obviously, and are aware of the fact that wastewater treatment facilities, in most cases, are not permitted to take solid waste. They are permitted to take pumpable materials. We are aware of that fact. Hydromechanical pre-processing. It's back to the old days where our grandmothers were using water and forces and friction to do the work. And our process occurs in 2 steps: dissolution and defibering in the pulp of the digestible organics into organic suspension, and the removal of the coarse and the light materials, and the removal of the grit materials in a 2nd step. And it is performed to facilitate disintegration of biodegradable waste to enhance the process afterwards. It's establishing the removal of the non-biodegradable contaminants. And we're using processed water. So we're not using clean water. And in fact, this is a picture of, for instance, a facility which is installed at Toronto. We have different sizes. So don't be afraid if you see on the left top the small guy in a big unit, because we have different sizes. But the waste is being fed normally in number 2. Then we perform in the cycle by adding processed water, the pulping, and in part of the cycle, we are removing on the 12th the big items, the bigger plastics, and the bigger pieces of materials in number 5, and then the rest goes to a degrading system, and depending on the amount of contamination, grit, sand, soil, we're running it a number of cycles through a degrading system. This, in fact, is what a system does. That's the perfect system. Here you see that we're performing the first task at 80 RPM. And that is where we establish a solution, and that's to establish things to happen like, and this is the CFD simulation, where you see that it shows the forces caused by the impeller, and that is causing different speeds of material and water flows and organic flows into the system, and will establish ultimately defiber and dissolution, and it will not cause disintegration of packaging material. That is what we want to establish. As for co-digestion, most of the digesters are taking materials which is pre-processed. Number one, it's pumpable. We have different solutions for that, smaller solutions. And then it goes in the pulping, where we then go through a cycle, establishing around 15 to 20 tons an hour, depending on solids level of the incoming mass. We're running an average of around 10% solids in the pulper to separate out the heavy materials, small pieces of plastics, and ultimately run it through a degrading system to finish it and remove small parts of grit, pieces of steel, etc. left. And this is a solution which could be positioned installed at, for instance, a co-digestion facility, and this is the size. Around 30 foot, 30 foot, 30 foot. On the right side, you see some of the performance materials, data, like the source levels, contaminant removals, throughput, uptime. And for your information, the whole system is fully enclosed and can come with a point suction for odor abatement, and can be also included, odor abatement can be included for the solution. And obviously we have different business models. As an example of a business model, like we did previously with Listec, where we had a sharing mechanism with Fairfield Soussan, where we invested and we operated it, and at our cost and our risk. By the way, we're negotiating the same type of structure deal with some of the utilities, which is based on a sharing mechanism. And in addition, we have also other solutions as required. Design build or operate, PPP, alternative models. Again, ultimately establishing a good performance, avoiding a lot of issues for wastewater treatment facilities, including the degrading. And the degrading part can be also provided standalone or as part of the process. For instance, for sludges, you can do a standalone solution. It's depending on the incoming material, on the contamination rate. The net flow is around 9,000 US gallons an hour for 1 unit. Gross flow around 40,000. And we're removing all particles, I think greater as 39 and 10, no, smaller as 39, and except for the minimum particles with a minimum size of 500 micron. Depending on the contamination level, we're running a number of cycles. What you see on the right is that we're introducing the incoming flow with high speed. That's where the separation occurs, and I will show you shortly in the video how that works. And there's a system where we then separate or even clean the grit and particles before they are released into a residual waste collection bin. This is on the left, the fact where you see how the system works from top to bottom. On the right side, you see the cleaning step.
Now it gets cleaned. There you go, there it goes again. Which is tank one? What? Which is tank one?
Of the system. And this is the result, as an example, Disco Road. Organically, you saw how bad that waste was incoming. Here again, a picture of how that looks like. And this is the suspension going into the suspension buffer tank and afterwards into the digesters, ensuring uninterrupted processing. To give you an example, at Disco Road in Toronto, after 10 years, the suspension buffer tank had no buildup of grit and heavies. And we believe that that is what operators like very much, because there's a lot of cost to clean out digesters. But it's also telling you that if that is not filling up, then pipes will have different costs to run them, to clean them, to maintain them, to operate them, to replace them, as compared with when they have to deal those systems with contaminated materials. And obviously, garbage in, garbage out, ultimately for the end product, that is where we can establish Class A product, like we do, for instance, Disco Road, the highest quality product for land application from that contaminated post-consumer source-separated organics. This, in short, is my little presentation as an introduction of the company and the technologies. Thank you. Do you want me to stop sharing, Janine?
Sure, yeah, we'll go back to our meeting format. Yeah, that was really interesting, Ward. So I didn't really get I'll start out with questions if that's all right, everybody. I didn't really understand the importance of not destroying the packaging.
It is very important for two reasons. The most important one is to avoid that you destroy pieces, the big pieces of packaging, which are into small pieces of plastics, very small pieces of plastics, very small pieces of steel, grit, etc., ending up in the end product, but also in the systems. You don't want that to happen.
I gotcha.
It avoids that ultimately, if you land apply your material, that you see the glitters, the glass, that you see the pieces of plastic, because if it's raining, then after you see the quality of the materials you have land applied. You don't want that. You want to know that you meet the guidelines with your end product. That's the reason. The second reason is that if you see how clean that material is, and it is in one piece, you also see that for capture rate, it's doing a good job. And why is that important? Because most of the penalty packing system, prestige system, most of the conventional system people are using, they don't establish high capture rates. Significantly different from what you really would like to establish if you want to divert. Two reasons.
Thanks, great answer. Does if anyone else has questions, just go ahead and unmute, raise your hand. Otherwise, I don't know if Tommy, if you wanted to just say hi and add anything to what Ward's. And now, could you just, where in the U.S. are you? You have a few facilities operating in the U.S., California?
Yeah, we have facilities currently in Canada, Toronto, in Montreal, and we are now working on the first contract in the U.S. in Fairfield, California.
California leads the way on they use a lot of anaerobic digestion, so that's good.
Yeah, and we're working on a project in the Northeast, but we're bound by an NDA. I can't talk about it.
Oh, good though.
In your area. But that is organics from mixed waste.
I'm just curious if you have any thoughts about why anaerobic digestion is kind of limited in use in this area. I probably can count on one hand, maybe two wastewater treatment facilities that have anaerobic digesters that are. I'm just wondering because it seems like the energy piece is the energy driver is there, but
You would think so.
as opposed to like California and other places that are doing it. New York does way more anaerobic digestion than we do here in the Northeast. I don't know. It was a head scratcher for me.
Yeah,
So,
I think
so Michael, I think, raising his hand.
No, I think that was Alex saying, yeah, it's a head scratcher. We don't know. We don't know.
it's highly political, I assume, right? So
Yeah, I mean, I know they're tough. They
wondered
can be
about it.
tough to operate.
I mean, yeah, talk to operators. Maybe I was going to say what you were going to say. Like an operator does not get paid based on energy generation. So you're asking them to add something to their system that is just one more piece of complexity. And for what? You know, what's the reward in it? They get to pat themselves on the back. The mayor shakes their hand. There's a nice picture. Okay, fine. Now, what if this additional complexity causes your facility to go down?
Yeah,
and
no, they're
stop
very focused on
operating?
permit compliance.
I mean,
and
yeah, there's permit compliance, but the downside potential risk for an operator, this is what they say to me, way outweighs kind of unless they're like some kind of a really motivated champion, you just want to do the thing, it really outweighs, that risk outweighs the reward. That's my impression from talking.
But that is interesting, Mike, because
That's
also
Alex.
we've experienced that too when we did, for instance, Listec. That's why we negotiated a deal where we said, no, it's at our risk. But
Yeah,
maybe
that will definitely make a difference in this sector.
Yeah, the treatment plant here in Montpelier did something similar, where there was something in the contract where if it worked, then it would be handed off. But the people who developed it had to do some period of operation or something. So there was some kind of thing like that. It wasn't a totally third-party owned, but
No,
there
it sounds like a hybrid, but that
Yeah.
was a smart way to do
something
it.
like that with a new anaerobic digestion facility. Combined heat and power. I think they may have already had a digester. I'm not even sure, and just been flaring the gas. But then installing a bigger digester and maybe taking more external material and putting in a combined heat and power unit. All of that change. They had something that their takeover or their ownership was contingent on the success of the initial operation.
Yeah, I agree, and I see what we experienced, for instance, in Fairfield-Sousson with Listec, is they had this empty biosalts processing building, and I think it was a lime operation previously, and they were not using it anymore. So we said, okay, why don't we do the following? We invest, it's our equipment, our machinery, we're paying you a lease for your building, and we're taking your material cheaper and allow us to take materials from third parties to make a business case and share the benefit. And that's in fact what ultimately was established. And Jim Dunbar told me that, and I don't know, is Jim on this meeting or not?
No, he's not on the call, but
Okay.
Biosolids people know exactly who that is.
Yeah, so Jim ultimately he's turned this into a big success, because I think that most of everything east of Sacramento or west of Sacramento is currently his customer. And specifically as regulations obviously in California on biosolids land application, they do for landfilling are completely different. That's one of the biggest.
No, there's big drivers out there again, regulatory drivers, not so much here yet.
And I think that what in the West, what you see is there's more pushed for Class A, what I believe, what I've experienced. And so you see that people are moving away from class B and other applications to class A because they have to. That's a big,
Yeah, I think that's a trend across the country that we're
Yeah.
definitely seeing. Yeah,
Yeah.
less and less class B
but I don't know, Mike, if you see, for instance, for opportunities for in the Northeast where you say, okay, if you would come in, you would say, we take the risk.
Yeah, I mean, like I said, I could probably name some facilities for you. I could just tell you where they are, and you know, we have that great example here, Greater Lawrence Sanitary, but they're located very close to one of these core processing facilities that takes food waste and just churns it up into a little slurry, and then they tanker truck it over there. I mean, that's not going to be realistic for some of these other anaerobic digesters operating. Yeah, there's a couple in Vermont, South Burlington, I know. There's one in Maine, Lewiston, Auburn. There might be another couple in Massachusetts. There's one for sure in Rhode Island.
Agawam.
Okay, yep.
Are you talking depackagers?
No, just
Or-
wastewater treatment facilities
Oh,
that are operating digesters.
Yeah, South Burlington, Essex Junction.
Oh, right, Essex.
Burlington
Okay,
has a
forget
couple of
Essex.
plants. I don't know who else runs digesters besides Montpelier. I had a list, but
Fellows Falls, Springfield.
Wow, there's a lot more in Vermont than I thought. I
Oh
gotta
yeah, there's a
update
lot
my
in
list.
Vermont.
Yeah, good.
Who else has digesters?
Anyone's doing co-digestion that you guys know off the top of your head?
Montpelier takes a bunch of waste from different haulers.
Yeah, so does Springfield. Bellows Falls does.
I'm not sure what it is. I don't think it's depackaging waste. You know, it's first of all, of course, it's going to be septic, I assume, but
yeah.
there's also, I think, food processing residuals that are going in there. That's a defined term
Yeah.
for us. It means something that's been through a food processing,
Yeah.
you know, creamery, brewery,
Yep.
that kind of thing. I
Yeah.
think that's starting to come to the Montpelier facility as well.
What about the depack in, where is that? Is that in Williston?
Yep, up there, Williston
Yeah.
Junction. I don't know if that's running. I mean, you make an investment like that, you've got to
Yeah.
feed it. On the other hand, we've had this depackaging
Right.
stakeholder group, and I don't know if that effectively shut down the ability to, I don't know. I have no idea. The other place that the stuff probably goes to or could go to is the Vanguard digester,
Okay.
that big digester in
Maine.
Salisbury,
Yeah.
Vermont, which is 1/3 manure, 2/3 food waste.
Yeah. And there's another thing which I was learning, for instance, in New York State. New York State, and maybe the other states in the East, they don't like facilities like this because everybody thinks that New York City will start shipping. And there was always a concern wherever you showed up, are you taking New York City waste? And that was then the end of the story.
Interesting.
Yeah.
Does anyone else have any questions? I'm hoping, you know, I'm rooting for anaerobic digestion to expand. I ran a treatment facility in Warwick, Rhode Island that had abandoned digesters just sitting there that were built in the 60s. It used to drive me crazy. I had one board member like, when are we going to demolish those? I'm like, no, we might be able to do something with these. But the superintendent didn't. It used to mess with his stringent nutrient permit conditions for phosphorus. He shut it down because of that. But
Oh yeah,
I bet you find a lot of abandoned anaerobic digestion facilities here that were built with federal funds that nobody operates.
Because the business case wasn't there. And that is one of the reasons that we were really focusing on co-digestion, because the capital cost of
That makes
doing
the
this
math
finishing
completely
solution,
different.
yeah. So so if you have only this pre-process step to go and you can work with the co-digestion or the digestion facility, the wastewater treatment facility, then what you do is you optimize capital use. and you
Yeah.
optimize operating circumstances and conditions, and by the way, that is very important in the US. Everything is about how efficient it is. That's one of the reasons that we are really looking at working with co-digestion facilities to let them do what they want to do without risk, but benefit from it.
Yeah, good luck. So I'm very excited to hear about this project. You're gonna let me know, right?
We stay in contact, and I'm hoping that we are welcoming our first contract shortly here in the US and then start going, and then we will certainly continue to work on it.
Great. Yeah, no, it seems like that's very needed if you're gonna go to co-digestion. Let's see, here's some chat things. Some additional information there for you. Ward and Tommy is, oh yeah. So Vermont
Perfect.
has Ben and Jerry's, and that's some good organic waste to
Yeah,
Yeah.
I mean, I just put this in
digest.
here because Purpose Energy is in Massachusetts, and they're building or have built, I can't keep track of a number of food waste digesters in Vermont. I don't know what their status is. Their website it wasn't really all that clear. A cream cheese facility, and I think that's not taking external waste. A creamery also, I don't think taking external waste in Agrimark and Middlebury. Then the St. Albans facility, I think, would be taking external waste. And I think the brewery facility they have already operating at what used to be Magic Hat Brewery, I don't know who it is now, that I think will take external waste as well, not just the brewery's waste.
Mhm.
Yeah, so those are some facilities that are gonna supposedly suck up this material.
Yeah, that's a good point. Not just treatment facilities, but other
Yeah.
operating anaerobic digesters might be interested in juicing up their biogas production, start taking
Yeah.
this stuff.
Sorry, it's not your it's not Nebra, but it's not wastewater treatment, but there's like all these different
Yeah,
pathways.
no, but it's still anaerobic
Yeah.
digestion, and I think
10 years ago, we thought this stuff was going to come to farms, and that sort of dried up when these food waste digesters were built, especially in Massachusetts, because we were getting stuff all the way from whatever, Gloucester, Massachusetts, all the way up to, Northwest Vermont, because there wasn't a home for it in Massachusetts.
Yeah.
So where's it going? It keeps shifting around where this material goes and what it is. And yeah, it's fascinating.
Mhm.
Yeah, it's
Very
like
interesting.
biosols. It's fascinating also where it goes.
oh yeah, I
Yeah.
agree. Something different every day.
Yeah, but what the tendency is ultimately shorter and shorter and closer to where it's generated, and that's how it should be. And
Absolutely.
that's why the focus is. We've built facilities, big facilities, and by the way, we are developing a facility in Oshawa, Ontario, 200,000 tons. But there's only a few places where you can do that. And we can do that because the Greater Toronto area, 6 million people, and growing to 10, 12, whatever, is one of the fastest growing areas. That's where you can do it. But for the rest, small,
Mhm.
because you want to have it close. You want it to be close and
Absolutely.
convenient and without any hassle. That is, in fact, where we believe that co-digestion should and probably will be very important in the future going forward.
I hope you're right. I think you are. Well, if no one else has any questions, I really want to thank you guys, Ward, Tommy. We missed William, but maybe I'll meet him at some point.
Oh, yeah.
Oh, yeah. All right. Well, thanks to the rest of you for joining us today. I just want to mention next up in the October that our lineup is we're having Professor McCutcheon come back from UConn to talk about that SCADA system that he's developing for anaerobic digestion operations. It's some Department of Energy research that's been funded. So, and if you have any suggestions for future topics, you can always let me know. You can suggest it on the webpage there. And thanks again for joining us today. Have a great Friday. Great weekend, everyone.
Thank you,
Thank you.
guys.
I appreciate
All
it.
right.
Bye.
Ward.
Thanks,
Bye,
everyone.
Tom.
Have a
Thank
good day.
you.
All
Take
right.
care. Bye.
See you.